Okay, we're going to do some double replacement reactions today. So the first one up here on the board is just salt solution. So I just took some NaCl and dissolved it in water. And then the second reactant, you can't see very well, I guess, on here because of the reflection, is silver nitrate, AgNO3. So when I pour that in here, okay, you can see it's a clear liquid. You can see right away that there's a change in color. Okay, turn to milky white. So we know that a reaction took place. So what we have to be able to do is figure out what happened. So what we do is we know our metals have to switch spots. So Na and Ag have to switch spots. Okay, so we're going to take the Na and put it with the NO3 and the Ag with the Cl. To do that, we have to make sure we have the correct charges. So Na plus 1 and NO3 is a minus 1. So the Na is now going to go with the NO3. Plus 1 minus charge, 1 charge, so we just get NaNO3. And now the Ag has to go with the Cl. Ag is plus 1. Cl is minus 1, so Ag, Cl. And then we have to balance that. There's one of everything, so this is already a balanced equation. Second one I'm going to do is salt water again. And a little bit of potassium hydroxide, which is a base. And in this case, you don't see anything happen. Okay, so what's that showing you is sometimes in a double replacement reaction, you'll get a precipitate form like this one did, okay, with a solid. Sometimes you'll get no change at all that you can see, but there was a reaction. Okay, so what happened in the second one is the Na and the K switched spots, okay? But we didn't get a precipitate from that. They didn't become a solid. So what we have is K going with the Cl. K is plus 1, Cl is minus 1, so we got KCl. And then the Na went with the OH. Na is plus 1, OH is minus 1. So we had NaOH. Now there's another part to this. Give me 1 second, I gotta go get my sheet. So what we have to do here is on the other side of your activity series, we have your solubility rules. So what we have to do is determine whether we got a solid or not. Okay, so if you look at this, we have sodium and nitrate. If you look at your rules and look at rule number 3, rule number 3 is nitrate. Okay, if you look there, it says that compounds containing the following are soluble. So that means this is an aqueous solution. This was dissolved in the solid. In the other liquid, excuse me, so there's no solid there because it's aqueous. Then our other product here is silver and chlorine. If you look at rule number 4, okay, it says halides, and if it's combined with silver, it's not soluble. Okay, so it says AgX, the X is chlorine in this case, and so they're insoluble. So what that means is this became a solid, and that's why it changed colors. Okay, so that is a solid there. The next reaction down here, okay, both of these were aqueous when we started, just like both of these. I didn't mark them, but they both are AQ. If we look here, we have rule number 4 again with the halides, okay, but this is not an exception. If we have potassium with the halide, it is soluble. So this was an AQ. It's dissolved. That's why we didn't see anything happen when this reaction occurred. There's no solid, it's still liquid. Okay, the other one is NaOH, and if we look here, hydroxide, all the way down here at the bottom, okay, it says Ca, Sr, and Ba, and anything from Rule 1 are exceptions, and it is soluble. So Rule 1 is alkali metal. If we look here, Na is an alkali metal, so it is soluble. So this is AQ, and that's why we did not see a color change or any solid form.